Good afternoon, dear students. Last class we discussed about fiber optics laser instrumentation. In that, in the second chapter, we discussed about optical sources and optical detectors. Once again, recall the same topic, and then we will see today our concept. Right? What is optical source and what is optical detector? Optical source nothing but is a device converts electrical signals into light signals. So who can convert? What are the available devices? The available devices are LED and laser. You know laser LED principle. So if you apply forward bias, recombination takes place, light is emitted in the form of heat. So you know laser we have three process: absorption, spontaneous emission, and stimulated emission. We are expecting stimulated emission because we are expecting high radiations. If you take a spontaneous emission, we are not expecting high intensities, very less intensities light we are expecting with this spontaneous. So always we prefer, stimulated emission with the laser. So these are all covered in the last class. Fine. So once again, you have to recall the optical communication link. So what is optical communication link? How it is established? So the optical communication link can be established with transmitter and receiver in between a optical waveguide, nothing but optical fiber. Fine. So today our class is in this optical communication side or the fiber wherever it is useful in the industries, they may require sometimes modulators. They require sometimes modulators. So what is a modulator? Generally, uh, you tell me the general meaning of modulator. What is modulation? So you have the subject like principles of communication, isn't it? So there you must studied about this, the meaning of modulation. So what is modulation? Modulation simply we can easily understood that nothing but changing the characteristics. So before going to know the character before going to know the changing the characteristics, the word modulator, it is better understand what are the characteristics of the laser available. So what are the characteristics of the laser available? So laser characteristics are generally as per our knowledge, we are going to discuss about 5 laser characteristics. The first one is uh, coherence. Laser is an optical source, no doubt it. It is going to convert electrical signals into light signals, fine. But basically this laser having some basic characteristics. Among these, the first one is coherence. What is coherence? Coherence means when the laser emits some light, the light waves, that if you observe the light waves are having same phase and direction. Same phase and direction. So that light waves having same phase and direction, that concept so called coherence. The laser output is always coherence. That is the first characteristics. And the second characteristics of the laser is high intensity. High intensity means, yes, you have other source, LED. In this LED, you tell me how much light you are expecting from the LED. Generally, if I speak, very less light expecting because the selection of compositions for a LED is different compared to laser, isn't it? So in this LED, we're expecting very less light, very less intensity. But if you come across with the laser, because of the characteristics of high intensity, the laser emits very high intensity light output. So that is the major characteristics of the laser. The third one is high directionality. High directionality. So high directionality means, so if you take a LED, you take LED output, and apply the LED output light to somewhere, the light may transmit from for a small distance up to a small, I mean, a less distance, very less distance, the LED output may transmit. But if we come across with this laser, because of the characteristics of high directionality, the laser light will transmit for long haul distance, very long distance. You are all experienced with this when we are observe the child, they are playing with some laser lights, isn't it? Laser light. So if I press a button, the laser light is out and that is placed for a long distance from one building to other building, isn't it? We can place it a long distance light because of laser characteristics, high directionality, high directionality. It is not possible with this LED. And one more characteristic is mono monochromaticity. Monochromaticity. So what is this mean? Monochromaticity. Monochromaticity means if you observe LED light, the wavelength of light is, say for example, 100 nanometer. You can spread the LED light maximum of say 100 nanometer wavelength. But we come across with the laser, you can spread the light in 1 nanometer. Up to 1 nanometer you can spread it. This is a specialty of laser compared to LED because of the principle monochromaticity. Right? That is, these are all the laser characteristics. Laser characteristics. Why we need to study these laser characteristics before going to these modulators? Because modulators are the devices, remember, understand clearly, modulators are the devices, they are ready to change laser beam characteristics, laser beam or laser light characteristics, isn't it? Just now we studied about laser, some of the laser characteristics, and we have more characteristics of the laser also. For example, laser having some frequency, some phase, some polarization, isn't it? And some maybe intensity, like this intensity. So these are all other characteristics of the laser, no doubt it. But why we need to use these modulators means because of these modulators we can change laser characteristics, laser light characteristics. We can modify it, we can change it as per our requirement. We can change it. So the question is, okay, we know the general meaning of modulator, right? But how it is possible? How it is possible? See, it is a simple diagram designed by IBM. Designed by IBM. This IBM company designed this a simple optical modulator. So what happens here? We have two inputs and one output. What are the two inputs? Two input is, one input is light, other input is electrical signal. Other input is electrical signal. By taking these two inputs to the IBM modulator, say simple optical modulator, we are changing the light pulses. See, these is called output. This is the output. So we are changing the output pulses. What we are going to change? We can change amplitude of the light pulse. You can change the frequency of the light pulse. You can change phase of the light pulse, or you can also change intensity of the light pulse. Intensity of the light pulse. As per our requirement, we can change it. We can modify it. So how it is possible? It is possible with optical modulator. Optical modulators. See, once again I am writing here, a device that modulates or varies the amplitudes of an optical signal in a controlled manner. Why it is the word controlled manner? Controlled manner refers to, because we have two inputs to the modulator. One input is nothing but laser beam, or is also called input light, laser beam or input light. The other input is electrical signal. Electrical signal means applied input voltage or applied input current. That is in our hand. So if it is in our hand, we can change, we can increase the current or increase that voltage. decrease the voltage or decrease the current as per our requirement, so that it will affect on the light amplitudes, phase, frequency, intensities are going to be modified. So we are using the word optical signal in a controlled manner. Controlled refers to we can change the voltage so that we can change the other properties of the laser beam. So that is the meaning of optical modulator. Generates desired intensity, color, the passing light by changing optical parameters such as the transmission factor, refractive index, reflector factor, degree of reflection, coherency of light in the optical system according to the modulating signal. See, the general meaning of this sentence is as per the given input signal, we can change the light signal parameters. How these light signal parameters are going to be changed means by changing the electrical input, other input. So, and if you change the electrical input, this device, which is called a modulator, the modulator is a type of optical material. We can change the refractive index also. If it can, we can change refractive index also. So if we change the refractive index of the material, which is working as a modulator, so that the light properties also be changed as per our requirement, we can also change. Next, see, generally, how many types of modulators available? Generally, as per your syllabus, we have three types of modulators, optical modulators. Three types of optical modulators are there. Of course, we have other types, but they are not included in the syllabus. As per syllabus, we have three modulators. The first one is electro-optic modulator. Electro-optic modulator. Next one is acousto-optic modulator. Next one, the third one is magneto-optic modulator. So these are all the three basic optical modulators, which are used in the industry sites, in the industrial instrumentation sites, or any process instrumentation sites. Wherever it is required, we can use all these modulators. Okay, we'll see one by one the meaning of this. The first one is electro-optic modulator. So what is electro-optic modulator? An electro-optic modulator is a device which can be used for controlling the power, phase, or polarization of a laser beam with an electrical control signal. Understand? Understand this word? The same diagram will depict here. See, observe the diagram. This is a diagram of simple example of electro-optic modulator. In this electro-optic modulator, there are two inputs: input light beam, laser beam, and input electrical signal, and output light signal, output laser beam signal. So in this, what happens? What is the meaning of this? Electro-optic modulator nothing but is a device which can be used for controlling the power, power of the laser beam, power and phase of the laser beam, and polarizations or any frequencies like this. We can change it. We can control it. Change means control. How do you control? With the application of electrical control signal. Electrical control signal. This can be done. How it can be done means because of the arrangement, so-called focal cells. Focal cells. So in this arrangement, we have to use possibly additional optical elements, polarizers. We can use polarizers between front and back of the modulator, so that it is possible to control the light parameters, right? And it is also called Pokel's effect. Generally, it is an electro-optic modulator, and the other name for this is because of we are using two mirrors. There are nothing but Pokel cells in the front and back side of the modulator. So it named as Pokel's effect, electro-optic effect, also called Pokel's effect. So Pokel's effect nothing but modification of the refractive index of a nonlinear crystal by electrical field in proportion to field strength. Generally, what is the meaning of this refractive index of the nonlinear crystal? See, in this IBM, in the place of IBM, you can place a nonlinear crystal. Non-linear crystal, you have to place it. If you place it, what happens? I will show one more diagram. I will show one more diagram. Just wait. Just wait. Yeah. See, in this electro-optic modulator, see, the simplest kind of electro-optic modulator consists of a crystal. A crystal. What is a crystal? Crystal nothing but lithium niobate. Lithium niobate is a one type of crystal is available whose refractive index, any material, any crystal having some refractive index. So core has some refractive index, cladding has some refractive index, air has some refractive index, diamond has a refractive index, isn't it? Likewise, any material having some refractive index. Fine. Similarly, in this electro-optic modulator, we are choosing a crystal. Crystal is made with lithium niobate. This crystal also having some refractive index. What happens? This refractive index is function of strength of local electric field. That means for a crystal, if you apply electrical signal, the refractive index is going to be changed. Then what happens? If I take electro-optic modulator as a crystal, as a lithium niobate, if I apply electrical signal, the lithium niobate crystal refractive index is going to be changed. Then what happens? If refractive index of the crystal is going to be changed, then what happens? That means, if the lithium niobate is exposed to an electrical signal, light, this is what happening. Light will travel more slowly through it. When light will fall on the crystal, the light will travel very slowly through the crystal. Why? The reason is refractive index of the crystal is modified because of the applied input, applied electrical signal. So applied electrical signal, if you vary the electrical signal, refractive index of the crystal is going to be modified such that the light may travel very slowly, such that the light parameter is going to be changed. See this I am writing here. But the phase of the light leaving the crystal is directly proportional to the length of the time it takes and the light to pass through it. That means what happens? When the light passing through the crystal is very slowly, the phase is going to be changed. So the phase of the laser light exciting an EOM, means electro-optic modulator, can be controlled by changing the electric field in the crystal. So that's what happening in this arrangement of electro-optic modulator. Very simple. In this electro-optic modulator, there is a crystal and there is some arrangement of focal cells. There are two inputs to the modulator. One input is electrical signal, which is controlled by ourselves manually or automatically, and another input is light beam, whose light is going to be modulated. So we can change this light phase, laser light phase, laser light frequency, laser light intensities, laser polarizations, all can be modified with these modulators. Right? In this electro-optic modulator, we are focusing changing the phase. You can also change polarizations, no problem. Okay, this about electro-optic modulator, and we'll see. You will see one more, um, one more type of, one more type of. Yeah, we will see one more type of. Yes, you will see other. Yeah, in this we can also see the shape, different shapes of these modulators available. Different shapes. See, this is the one type of crystal. Is one crystal modulator. Is a modulator. Is optical material. Is optical material. These are nothing but some mirrors, focal cells, or this is a rectangular shape, or this may be circular type. I mean this also called round shape means. Um, Circular shape, or it may be other shape. So any shape of crystal you can use for this acting as electro-optic modulator. And uh, yes, with this electro-optic modulator, we can also change phase, amplitude, polarization, frequency like this, isn't it? And see, this is another example how the phase is going to be changed. How the phase is going to be changed. See, at one side, we are applying input carrier wave, nothing but it looks like laser beam frequency. It is a laser beam frequency. Carrier means here laser beam, and modulating means our input, our actual input, our control input we are giving, M of T. FC nothing but carrier. These two inputs are given to electro-optic material. Electro-optic material means, isn't it? If you apply two inputs, as per this carrier, we can change the this control signal so that we can modify the output phase. See the phase, the signal phase. This is called phase modulation. So these, how it is done, it is possible with these transparent electrodes or focal cells or polarizers. Next, phase also be changed. You can also change the phase. See this amplitude of the light signal can also be changed. See, is a phase modulator nothing but electro-optic modulator. It is nothing but a crystal. It is a crystal, right? So from this we are applying light source with this number of mirrors, reflecting mirrors. We are taking 1, 2, 3, 4. We are taking 4 mirrors in this. 4 mirrors in this. So whatever the light we are placing on the modulator, the same light can be reflected and again reflected and placed on the third mirror, placed on the other mirror. We are the same input is focused on the other mirror, and the same input also given to the modulator, phase modulator. So this signal and with modulating signal, these two are combined, and we can have amplitude modulated signal. This is called amplitude modulated signal. So what do you mean by amplitude modulation? AM nothing but amplitude of the carrier signal is amplitude of the modulating signal is varied. Amplitude of the modulated signal is varied with this available carrier signal. So that is called amplitude modulation. So amplitude is going to be modified. These two are combined, you can get superimposed AM signal. This is called superimposed AM signal, right? We don't want superimposed, but we want only AM signal. AM signal, amplitude modulated signal. So it is done, this arrangement is so called, who can done this arrangement is a scientist name is Mach Zehnder. Mach Zehnder interferometer is also called Mach Zehnder interferometer. That person derived this, this relation, how to get a phase modulation with this electro-optic modulator. And this is about electro-optic modulator, right? And so we can also change polarizations. Polarizations also we can change. And here we have the second type of second type of modulator is optical modulator is acousto-optic modulator. Acousto-optic modulator. In this acousto-optic modulator, the word refers to acousto. Acousto means what? In the previous example, what is electro-optic? What is electro word? Electro word refers to applied electrical signal. Clear? Is a control signal. With this control signal, by varying the voltage, the input light laser beam parameters are going to be changed by changing modulator's refractive index. Here also, acousto-optic modulator, AOM, means the word acousto refers to sound. Acousto refers to sound. So with this sound signal as control signal in our hand, as our control signal, we can change refractive index of the medium such that we can change laser beam parameters, laser beam characteristics, like phase, like polarizations, like frequency, like amplitude, like frequency. Any of the parameters you can do by using acousto control signal. Acousto control signal. Clear my point? This is the arrangement. See this arrangement. This arrangement having input signal source. We are giving the input signal to the transducer. Transducer is nothing but here. Say for example, the input is going to be converted into sound. Who can done this? What type of transducers they are using for converting input into non-electrical into electrical into non-electrical? What is a sound conversion? What is this? Acoustic transducers. They will convert this electrical into non-electrical sound signals. So with these sound signals, they are passing through this medium. So when the light is when the light fall on this optical medium, it is optical medium. In this medium, this optical light will cross the sound signals. This optical light, laser beam light, will cross the sound signals. So when these light signals cross the sound signals, the light intensities, the light signal parameter is going to be changed. That is going to be changed, right? So we can get out of phase. See, it is undeflected beam and it is deflected beam. It is acousto-optic material and is acoustic absorber. Whatever the sound we are generated, that is absorbed in this material. But what happens? What is the basic principle of this? So we are simply converting the input into acoustic signal. So when the light passes through acoustic signals, the beam is deflected. The light beam is deflected. When the light beam of the laser is deflected, the parameter is going to be changed, so that we can change the laser beam characteristics. Of course, we cannot change all. we can, as per our requirement, we can change by modifying the structure of the acousto-optic modulator. So this is the second type of modulator as per your syllabus, nothing but acousto-optic modulator, right? Next, yes. So these are all what I discussed across all this. And the third one is magneto-optic modulator. You can easily understand this magneto-optic modulator. So in the first case, electro. Second case, acousto. Third case is magneto. What is the word magneto? Magneto is a control signal. Magnetic is nothing but is a control signal. Again, with these electrical signals, you have to get magnetic properties. These magnetic properties will change the laser beam characteristics. Otherwise, the magnetic principle, this property will change the material refractive index. So when the material refractive index is going to be changed, no doubt the light parameters are deflected, the light beams are simply varied or simply modulated, isn't it? That's what the magneto-optic modulator. See the diagram. In this diagram, here we have light input, incident light. It is incident light, and this is magnetic coil. It is magnetic coil. So with this available electrical signal, with the available control electrical signal that is applied to this coil, so when the current flows through this coil, it will magnetize. When this total material is magnetized, it is magnetized. Because of this magnetic property, the material refractive index is going to be changed. It is also the magnetic property is also called Faraday rotator. So because of magnetic principle, this medium is going to be rotate by 45 degrees. Rotate by 45 degrees like this, as per the diagram. See, so for this purpose, we are providing two polarizers. One is vertical, and one more is at an angle of 45 degrees. We are provided two polarizers. So when the light will fall on the optical medium, and this rotator, Faraday rotator, it will deflect by 45 degrees. And already we have again another 45 degrees. So this incident angle and output light, which is polarized, is these two are right angle. So what happens because of rotation, because of Faraday rotator? How to get Faraday rotator? Because of magnetic principle, by changing the electrical voltage to this structure, we can control the polarized light of the optical beam, polarized light of the laser beam. We can change phase, we can change polarizations, isn't it? So these parameters are going to be changed because of magnetic principles. So it comes under magneto-optic modulators. So these are the three types of modulators available in the syllabus. So you have to, it is very simple to understand. Draw the diagram, explain the principle, right? It is a very good question for examination point of view. Very simple. But remember, these modulators are very useful in the instrumental side. Generally, where these are useful means wherever we want to measure any unknown parameters like velocities, velocity of the moving body, or any accelerations, isn't it? Uh, like this, wherever it is required in the industries, we can easily apply these modulators. We can easily measure the unknown parameters. So this is our today class, right? And um, okay, you have any doubts, dear students? You have any doubts? You can ask through chat box. Otherwise, you don't worry, my dear students. Once again I am I mean requesting you. You don't worry about the timing, please, because I am flexible. If you want, what time you want, because we have two subjects. One is Foley and one more is AI, analytical instrumentation. So Foley is almost, we are in the second chapter, one and a half chapter. Remaining half chapter is pending. But for first mid, we have very less time. I have to complete the remaining half chapter and two chapters of analytical instrumentation. It is within a span of less span. It is very difficult to clear explaining, and all the concepts very difficult for me. So that's what I am thinking, that I have to cover some of the topics by adjusting my time at my home. If you are available, you can join. Otherwise, don't bother. If you are not available, you can see the video. I will send you YouTube link today, by tomorrow, probably by tomorrow, for a complete video classes. Right now we have 5 to 6 classes I have taken. For complete all the videos, I will send you the YouTube link or my blog link, right? You can watch the videos. You have any doubts, you can ask and clear all your doubts. Don't hesitate, and don't think otherwise. We are not ready for uh, in the morning time, and we are available in the college time. So that is, if you are comfortable, you can join. I am not forcing you. Hello, I am not forcing you. If you are comfortable, join in the morning class. If you are not comfortable, just watch in the YouTube. The same class you can watch in the YouTube. And if you are comfortable in the college classes, if I have a time in the college, definitely I will take class like this. Don't worry. But my aim is, I want to complete the syllabus with pin to pin explanation. I am thinking like this. I want to complete the two subjects of 4 chapters pin to pin, right? For first mid syllabus I have to complete. That's what my aim. If you are supporting me, or if you cooperating me, I will explain all the concept in detail. I am ready, right? Once again, I'm appealing you. If you are comfortable, you can join. Otherwise, watch in the YouTube. The same class you can watch. Don't worry. I'm always favorable. I am always favorable to the students. Your wish. That is your wish, right? And one more, I am going to appeal. By within 2-3 days, we will complete this half the chapter of Holy, and I will give you important assignment questions. Right? You have to go through it. You have to complete your assignment and submit. Right? That these questions are very much useful for your examination purpose also. That's what I am thinking. Right? Don't think that otherwise, please. If you have any doubt, please call me. Please call me and tell me. Right? Uh, okay.